Hello friends, my name is Vivek Sharma. Today we can cover this interesting problem that's called remove linked list elements. So in this problem we have been given a linked list of integers and we need to remove this value val that exists in this linked list, right? So that's what we need to do. What I did, I copied this linked list on the whiteboard and here we can try to understand. So this value 6 we need to remove from the linked list. So we can remove this guy, we can remove this guy. So the resulting linked list will be 1 2 3 4 5, right? So this should be the output. All right, now this is pretty straightforward to understand this problem. And now let's come to the solution part, how we are going to solve this problem. So let's say first of all what we need to do, we need to check where 6 exists, right? And how we will be checking, this is like linked list, so we will be checking by traversing, by doing like node dot next, node equals to node dot next, something like this. Okay, so if we consider this as a node and then we will keep traversing, if node equals to node dot next and then node dot next, if it equals to 6 then just go ahead and remove. If does not if it is not 6 then we will keep traversing. So for example in this case it is 6, then what we will do, we will remove. And how we will remove, because it is all the pointer waste, right? So in order to remove this, what we will do, we will this next we will point to 3, right? So current, let's say this is node, right? So node or current, any name we can take, but let's say here its name is node. So node dot next we will do node dot next equals to node dot next, right? So our code will be something like this: node dot next equals to node dot next, right? Right, in order to change these pointers. So this will be our code. So node dot next means node dot next is to next of 2, and that will be assigned to node dot next dot next. So node dot next is 6 and that next, another next is 3, so we will be assigning this, we will just be changing the pointers. Okay, and now we will again, so now our the new node is 3 and then we will be checking, okay, if node dot next exists, if node dot next exists and if it equals to given value or not. So it does not have the given value, then simply what we can do in that case, we can simply do node equals to node dot next, right? Node dot next. If val does not match, right, then let's do node equals to node dot next, right? Node equals to node dot next if val does not match. Okay, so if val does not match means this is the condition. If val matches to the to node dot next, then we can assign node dot next equals to node dot next dot next. So now our node is here, pointer is here, we will be checking, okay, if or if let's say if pointer is here at the 3 and then node dot next is 4, does it match 6? No. Then we will do node equal to node dot next and then it is at the 4, then we will say, okay, node dot next, does it equal to val, that is 6? No. Then we will say node equal to node dot next. So we will again execute this code and then we will check, okay, does node dot next equals to 6? Yes. Then we will do node dot next equals to node dot next dot next. So what is happening here? Node dot next equals to 6 and then node dot next equals to null. So what will happen? Node 5 dot next will be null in this case. Okay, and then 6 will be removed. All right, so this is simply we need to change the pointer. Now consider the other cases as well, right? So let's say this is the situation and given val is 1. Okay, so what we need to do here, we need to remove node 1. Okay, so we need to remove node number 1. Now we need to remove this guy as well. So as per the earlier logic, we were saying, okay, just check the node dot next, right? Just check the node dot next, and if node dot next is equals to val, then just change the pointer. But what about this case, right? Here we need to check, we need to delete the first node itself, so the output should be 2, right? So how we will handle this particular case, right? So in order to handle this case, what we need to do, we need to add some kind of a dummy pointer here as well before 1, right? to handle this case, or if it is single node itself and we need to delete this. Let's say for example our linked list is containing only one and the deleted value is also one, then what we need to do, we need to delete this and we need to return the empty linked list, right? In that case also we need to have some kind of the dummy node. Dummy node means, let's say I created another dummy node that's called 0, that value is 0, and that no dummy node dot next we will assign this node, right? One head pointer, right? Head node, right? And then we will checking, okay, dummy dot next, does it having equal to value or not? So given value, so given value is 1, and if it is having the value, then what we will say, dummy dot next equal to dummy dot next, right? So the same logic, right? Here in place of node we will be checking dummy dot next equals to dummy dot next, right? That's it. And if val does not match, then dummy equals to dummy dot next, as simple as it is, right? So if it is matching, then basically apply the same logic. The only thing is here it is dummy, right? So dummy will be having now 2, and then in the end let's go ahead and return dummy dot next, right? So in the end what we are going to return, we will be returning dummy dot next. So return dummy dot next. It will make sure that it's returning the head pointer, whatever the head pointer is assigned. So in this particular case, head pointer will become 2, right? 2 will become head pointer because we change the pointer, right? Dummy dot next equal to dummy dot next dot next. So now dummy dot next will have 2, and that's why we will be returning dummy dot next. So it will be having 2. Similarly, we can apply dummy pointer here in every case, right? Here also we can have another dummy pointer, right? We can have another dummy pointer that's 0, and that next we can assign to 1, because we never know, right? It can be always be the head pointer as well that we need to delete, right? It can be head node as well, not the pointer. It can be head node as well that we need to delete, and then in that case we need to use the dummy pointer, or it can be even the single node, right? So let's say this is our node 1, and then the given value is 1. We need to delete this. How we will delete, right? So in that case we need to take some dummy pointer, let's say 0, and then we will assign this 0 dot next equals to 1, and then what we will check, okay, this value is matching with dummy dot next. Then what we are going to do, the same logic here, right? So dummy dot next equals to dummy dot next. That's it, right? And dummy dot this next is null here, right? Because there is no value. So dummy dot next, what we are assigning dummy dot next right now, it is 1, but we will be assigning dummy dot next equal to dummy dot next. So we will be assigning 0, and that is pointing to null, right? And in the end we are going to return dummy dot next, right? We are returning dummy dot next. What does that mean? That means dummy dot next is null, so we are returning null here. Okay, so we are returning null. So that's pretty simple, right? And if it value does not match, then let's go ahead and keep moving the pointer, and keep moving the pointer means dummy equals to dummy dot next. So it is simple traversal itself. Let's go ahead and quickly code this thought. Okay, so let's go ahead and take dummy pointer here, new list node, and then let's say 0. Okay, and this dummy dot next, let's assign to head. Okay, and list node, let's say node itself. Okay, so node, we are taking another pointer, and that's pointing to dummy, or let's say this is current node itself. So we are saying this as a current. We can take any, whatever the name it suits or more intuitive. Okay, here I'm saying current so that it will be always pointing to the current node. So what we will be doing, while current is not equal to null, what we do, current equal to current dot next, right? That's the simple code that we do, right, in the linked list. So here we did not apply any logic, but this is the simplification that we did. Like whenever we traverse any linked list, we always do current equal to current dot next, so that we can move to the next linked node, right? So let's say we are having any linked list here, right? So 1 2 5 3 9. Okay, so this is our linked list. Now we need to move from one node to another node. How we will move? Current equal to current dot next, current equal to current dot next, current equal to current dot next. So every time current will be pointing to the next node. So that's what exactly we are doing here. And in the end, we have seen in our approach on whiteboard that we are going to return dummy.next, because dummy.next have the head pointer. So head pointer we need to keep somewhere, right? So let's say if this is the dummy pointer and it's pointing to its dummy 0.next is equal to this head pointer, so it will be, we will be saving this head pointer here, right? So we will be returning dummy.next. So this head pointer will be saved, but the current pointer will keep moving, and current pointer, with the help of current pointer, we will be changing the pointers, right? Now let's apply that logic. Okay, so now let's say if current dot next is not equal to null, and this is by the way the same logic that we discussed here, current dot next dot val equals to val, then what we are going to do, current dot next equal to current dot next. So current dot next we will be assigning current dot next equals to current dot next dot next. That's what we need to do. Else we need to do this guy. Okay, so that's simple, right? So current dot next, let's come here. Okay, so let's say our value is 2 that we need to delete, right? So 2 is the value, and then current dot next is right now 2. Then what we need to do here, let's choose different color, blue color. So current dot next is 2 right now, and we need to do current dot next equals to current dot next, that is 5. So current dot next, then it will be pointing to 5, because current dot next we need to assign to current dot next, that is 2, and dot next, that is 5. So we will be assigning this node to 5 now. So 2 will be removed, right? That's what we need to change the pointer, and that's what exactly we are doing here. Current dot next equal to current dot next, and if this value does not match, then just move to the pointer. For example, if it pointer comes to 5, and then it will be checking, okay, does this 5 dot next equals to 3, the 5 dot next equals to 2 or not. 5 dot next is equals to 3, not 2. Then what we will do, in current equal to current dot next, so current will be moving to here, right? So that's what exactly we need to do. Okay, and let's consider this quiz as well. So let's say I'm having 1 2 2 5, right? And now we need to delete 2. Then what we are going to do, so current equals to here, right? So 0 is pointing, 0 dot next equals to this guy 1. So this 1 we will be checking, okay, is dummy dot next equals to this guy, I mean the head, right? So dummy dot next equals to head, and then dummy we are getting pointed by current, right? So current is pointing to dummy right now, right? So current is this, and then we will be checking, okay, does current dot next equals to val? No. Then what we will be doing, current equal to current dot next. So current is pointing here, now current will be coming here, and now we will be checking, okay, that current dot next equals to value, yes. So then we will be changing this pointer to this, and now current is current dot next is pointing to here, but current is still here, right? Now we will be checking, okay, does current dot next equals to val? Yes. So now what we will be doing, current dot next equal to current dot next. So now current dot next will be pointing to here, but current is still here, right? And now we will be checking, okay, current dot next equals to 2 or not. So current dot next in this case is 5, so it does not equal to 2. Now we will be doing current equal to current dot next. So now it will be moving the pointer of the current, right? So here the important observation is we are moving only the current pointer when the value does not equal. Otherwise, if the value is equal to given value, then we are just changing the next pointer. We are not moving the actual current pointer. So that's the demonstration I wanted to show here, just to make it a little bit more clear, right? So if we see here the code, we are moving the current in case the value does not match, right? So we are moving the current pointer, otherwise we are just changing the next pointer of the current, but we are not moving the actual current pointer, right? So that's what the code is. Quickly, let's go ahead and compile first of all. So looks like it's getting compiled. Complexity wise, it will be linear, order of n, and the space complexity will be order of 1, because we are just taking the pointers, but we are not taking any additional array. So these are just the pointers, right? New list node, we are just taking one node and then we are just changing the pointer. So we are not maintaining any additional array or data structure or anything. So it will be order of 1. Time complexity, in the worst case, we have to traverse each and every node. So it will be the linear complexity. Let's go ahead and submit this one. So looks like this is working fine, right? And let's so see this, how misleading this is submit. So earlier it's 2 millisecond and the same code is 1 millisecond. So this is not trustworthy that much, but yeah, it's fine. So uh, this is the uh, problem, right? Now let's have a quick recap before ending this video. This is to remove the linked list elements, right? So what we need to do, we have been given this linked list, right? And in this linked list we have been given one value as well, and that value we need to delete from the linked list, right? So it have been messed up actually. So 1 2 3 4 4 or 5. So let's say we have been given this value, let's say 4 we need to delete. Then what we are going to do here, uh, we are taking first of all the dummy node. Why we are taking the dummy node? Because the dummy node, the help of dummy node is, let's consider the edge case, we need to delete one as well, right? Then we should have somewhere the dummy node, so that we can delete the first node as well, or only node. If it is there on in the linked list, then this dummy node is pretty useful, right? So then what we are checking, if dummy dot next equals to given val or not. So let's say 4 is the node that we need to delete, right? And then it will be checking, okay, dummy dot next equals to 4 or not. If it is not, then we will be simply, what we are doing, we are just doing node equals to node dot next, right? Else if, so if value is match, right? If value matches, then what we are doing, node dot next equal to node dot next dot next, right? So here basically, if for example my pointer is here, right, after traversing, so like let's say 1 does not equal to 1, 1 does not equal to 4, then current equal to current dot next, so current will come here. And then 2 does not equal to 4, then current equal to current dot next, and then current will be coming here. And then I will be checking, so I'm checking current dot next, not the actual current, right? So whenever I am in the dummy, I'm checking current dot next. So current dot next is 1. Does it equal to 4? No. Then current will be coming here, current equal to current dot next, and current come here. And then I'm checking current dot next, 2. Does it equal to 4? No. Then current is coming to here, current equal to current dot next. And then it's checking current dot next is 3. Does current dot next equal to 4 or not? Right? So current dot next equal in this case is 3. So I'm just moving current dot next here, current equal to current dot next, and then 3 is coming here. Does current dot next equal to 4? Yes. So what I'm doing, I'm just changing, I'm just applying this condition. So current dot next equal to current dot next, right? So still my current is pointing here, but I change the next pointer. And now I will be checking, does current dot next equal to current this given value? So current dot next equals to this given value. Then what I'm doing, current dot next equal to current dot next, right? This code. And now current dot next is pointing to 5. Still remember, the current is still pointing here. And now it will be checking, okay, 5 does not equal to 4, 4 is different than 5. Then I'm applying this logic, current equal to current dot next. So now current is pointing to 5, right? And now current is pointing to the last node, but we already stored head to the dummy dot next. So if we will return dummy dot next, right, if we will return dummy dot next, that still will have the head pointer. So dummy dot next will still have the head pointer, and that's what we are saving. So this was very quick recap of this code. And once we understand this concept, then the code is straightforward. We are just applying the same code here. So hopefully this was useful. Thanks a lot. Have a good one. Bye.